Hello guys, and welcome back to the sim here in Brunei. This is my control column floor and my new control column assembly, well, part of it. This has been one of my biggest projects and has gone wrong so many times in the past few weeks. From printer failures to just getting the dimensions wrong from the manufacturing firm. So I designed the base frame here, which you can see, which is just a big U-channel shape. It's made from 38mm stock steel, and it's just welded left and right. On each end is a 20mm stud. Put that down nice and carefully. Amazingly, I randomly came across some bearings downtown, and these are 20mm internal diameter 6204 bearings. We need one at each end. That should help the pivot point. All we need to do is create the design on Fusion. Let's see how it goes. Here's our two bearings and holders. I think they turned out really well. And I've just realised I actually haven't tried the bearings on the shaft yet. That was a bit of a silly idea. So I'm not too sure even if we have to use a hammer to put these on with. There we are, yes. Oh no. In fact, the fit is a bit too slack. There is a bit of play in the bearing, but you're not going to notice that at the other end. With the bearings off, let's get the PVC pipe on and the PVC pipe adapters. Now that our paint is dry on the PVC pipe, I'm going to put that to the side for a second. And so the pipe doesn't move around on the control column steel base here, we've got two kinds of 3D printed adapters. We've got the completely square sectioned that goes all the way through and will sit at the base and halfway up. And then we've got the top caps, which will allow the shafts to pass through. This will make a lot more sense in a minute. Now that does feel absolutely solid. Of course, the test is, can I pick it up with the PVC tubes? And I can. There's no movement and it's heavy, but it's good. So now in front of me is a forest of parts. Now we don't need all these parts, but these are just some of the prototype stages that I went through to get to where we are right now. And because my Ender 3 has broken, the PTFE tubing, the little connector has failed, which means the tubing doesn't stay in. In fact, let me just remove that jam. There was the jam that blocked up the nozzle, which forced the tubing out. And ever since that happened, it's never worked since. It's only 3 weeks old, which I'm a bit gutted about. However, I got the most important parts done, and I'll show you those in a second. But every other part now has been created on my old Tronxy A8, which is still going now, printing the 757 throttle. That thing has not had a break for about a year, I think. The print quality is terrible compared to the Ender 3. The Ender 3 print quality is amazing compared to the Tronxy A8. However, let me show you two examples. So we've got, this is prototype 1, prototype 2, they're the exact same thing. I tried two different things. This is a 0.2 print, and this is a 0.1 print. 0.1 print is actually far superior to the 0.2, which is what you would expect. And the 0.2, I didn't use any support, so you've got a bit of furriness on the inside. That wasn't really the main problem. With the 0.2 and no support, the bearing sizes weren't quite correct, and I had to actually heat the bearings up. Here's a pro tip, should I say. If you can't get these bearings, once you print them out, to fit in the slots, because they will fit if everything goes properly, just heat them up with a heat gun and sit them in there, and the unit will take the shape of the bearing. That's so much easier than reprinting one of these, which I think if you do for a 0.1 print is about 24 hours just for half a side. Not what you need to find after 24 hours to find that your bearings don't fit. Now on the other hand, if you use support, it looks gorgeous on the inside, it looks gorgeous on the outside, and the bearings are perfect. Another pro tip, if the bearings do have a bit of wiggle and you really don't want any wiggle, in fact, this rear one has got a bit of wiggle, what I'm going to do is use a bit of tape just to expand the diameter of this, and I'll show you that in a minute, because you put so much force through the yoke that you do not want any play. So with the control heads, we've got these little noggins, and the reason why I made the noggins was so you don't have to 3D print any support structure on the base and you end up with a perfectly flat mating surface. These noggins just click into place. I'm glad that worked because I've not actually tried this yet. Not a chance. Yeah, okay. Oh yeah, that one was a little bit tight. That's how noggins fitted, and they're going to help relieve the loads when you push and pull on the control column. Next up is to see how our bearings fit. Right, go to the close-up camera on this. There is a slight bit of play in there and I really want to remove that. Out comes the masking tape. Now really I've got an option here. I can adjust the design by 0.1mm smaller to take away the play. But I don't think that's such a good idea when you use people's different machines. Adding a bit of tape like this really isn't that hard. Got a bit of tape around them. Oh wow. That is absolutely perfect. That was just pure luck that 1.5 times was the exact diameter I needed. So this is the yoke shaft. We've got two different kinds, and I'm going to use the two different kinds for the time being because I've only managed to print one set yet. But this is the modified version, and it's got a slight taper. So looking at this camera, on the left you can see that it's square shaft, and on the right it's taper shaft, so it gets tighter the more we squeeze it. And we're going to use the taper shaft because that's the modified version, and that's going to go through there hopefully. Of course, now this is a tight fit. Wow. Now those bearings are a really tight fit on that shaft. Now these orange spacers, they set the mesh in depth. So these can be adjusted height-wise to set how much pressure we put on the gears. And of course, then we need the gears. So let's see if we can get this gear down to the base. Okay, so there's a hole for a bolt to go through there, or a machine screw, 4mm. We're not going to put that in yet because I want to check the mesh in depth whether the two parts fitted. Now this adapter shaft has already been adjusted to be bigger. I just haven't had time to print it yet. What you're seeing, every part you're seeing tonight, because it is late here, is only prototyping. Once I've proven this all works, I will then go back, use the best quality print I can, and use it for myself. I am now going to drill the gears here and here and permanently attach them. Let's put the other half on. Before I put the other half on, I wanted to show you this was the last one I printed, and of course what happened was we got a bit of warping in the end here, which kind of ruined this print completely. And hopefully, perfect, those two have gone together nicely. There we go. And you can see how much warping happened on this half here. It's quite a big gap. Time for some screws. And there we have our first working head unit. Now I know a lot of you are worried about the strength of the gears, and we'll find that out when we do the testing at the end. I've already tested it a fair bit already, and it seems quite good for what we're going to use it, but I guess you want to see that as well. Now that we've got our first yoke control head complete and working, put that to the side. We need the torque shaft to fit into the base. Now this one will fit in there absolutely perfect. However, because we need two control heads, we also need two control tubes, torque tubes. And before I fit it, I'm going to use this as the master because I know it works perfectly, and create another one. Change my glasses. Let's get this cut. There we go. I'm going to insert the torque tube. I have got a sneaky red marker on there so I know exactly where it needs to go. And all we're going to do is tighten the last bit up. And we have one control head to slide into our PVC base. And hopefully this is just going to slide in through the top. It only just fits because it's going to hit the roof. It's time to mount the bearing support for the cross tube. I've got a curvature in the top to follow the contour of the PVC pipe. Now this is the top shell to the centering mechanism, and that just goes roughly in the middle and presses onto the assembly like that. So for the gearing system at the base of the column, we need a bearing support to support the cross tube that runs all the way across the bottom and enters the centering mechanism. Again, this bearing is a 6204. That will just push in. With our bearing in place, I'll just use a small M4 washer and M4 bolt to hold the bearing into the bearing hanger. Of course, you wouldn't have to do this if I lived in the UK or in the West. I'd just go and buy this bearing hanger assembly from Amazon. So before we attach the bearing assembly, I've got my pre-mod collar, which is in green, and my post-mod, which has already had an adjustment, and this works much better. It's the green, has 8.2mm holes directly in it, and the blue has elongated holes, which makes the fit so much easier. And that becomes even more apparent when we come to the centering unit here, which also has 8.2mm holes for the bolts. They're too tight, they don't allow any flex, don't allow any movement to put the pieces together. So I found by elongating the holes in the assemblies, the actual build is a lot simpler. Let's get this done. Now, because when I got this manufactured downtown, they didn't drill the holes exactly center, I've had to make some centering plates, and they're just a hole in the middle which will hold the shaft in the exact center of the square beam. And they just push on over the top. They've got 2 holes in for attachment screws to hold them in location. And then we've got our primary gear, which is orange, and that will hopefully just slide on over the end. Next up is the centering shaft, and all we've got to do is push the bearings onto the center unit. With our centering shaft prepped, it's going to push our bearing hangers on left and right. Here's our centering mechanism. So hopefully now this will just mount to here like so. These blocks are the centering mechanism, and what they do is they clamp around the 2 ball bearings and hold it central. Here is the previous version. It's a lot smaller, a lot more compact. But what I realized was, if you really want to beef up the amount of pressure that's there, there's now 3 different location holes for 3 different springs. So it means you can add a lot of force. So next up is our adapter shaft. All this does is take the 20mm internal diameter and adjust it to whatever size torque tube you're going to use. For me, it's 19.1mm, really bizarre size, but I'm going to guess that's pretty similar to 3/4 imperial. Then we get this adapter shaft fitted, the final torque tube in, and we get to see if both the control yokes work together and if the centering mechanism then comes online. That's prototype and assembly done. It's now time to take it off the bench and see if it works. Here we are back inside. Now, the control column you see behind me is a couple revisions on later than in the last clip. The last version failed. It worked for about 10 seconds before it all went horribly wrong. And what had happened was I got the meshing depth of the 2 smaller gears completely wrong, and they were only just touching the bigger gear, and it was causing them to skip, and of course eventually with the force loading it snapped the gear, the teeth off the gear. This is where this big grey one comes in, and so we've gone back to 1:1 ratio. The teeth are a lot bigger, there's a lot more surface area in contact, and it removes all the play. Let me show you revision 623 and how it's now working. So here's our control column, and you can see it works absolutely amazing. Now, really pleased with the operation. There is a little bit of play in this control column here. It's because the shaft onto the control column yoke, there's a bit of the gap is too big in there. This is actually revision 1 of the control yoke. As you've probably just seen quite recently, we're about revision 8 now. This is revision 2. it's a lot smaller. It's a little bit more rounded. However, revision 8 is kind of mastered, and you've probably seen that online already. I'll put that back on. This side, which is the captain side, also has a bit of gear meshing problem where the gears are not pushed together far enough. So I need to open the control head and put a bigger spacer in there. So down to the operation. This is proven the left and right. Works really nice. But because we've gone to a 1-to-1 ratio rather than a 2-to-1, now the centre of mechanism locks out past 45 degrees. So it will return to 45 degrees, no problem. But as soon as you go past 45 degrees, it now prevents a mechanical lock because we've got a mechanical jam here. And if you go past 45 degrees, well, things become really bad and it actually locks out the other way and inverts the control columns and now centres them upside down. So I'll put that back. That's where revision 627 is going to change the centre of mechanism. Now that is going to be in another video because this has already taken over 6 weeks to print all this out, trial it, find it doesn't work, reprint it with the amendments, and we have gone through a serious amount of revisions. So much so that I've actually restarted the design on Fusion over and over and over to get rid of all the bad data in the designs. So we're going to a multicam process. Again, if you've been on social media, I've actually published that and it's ready to be filmed as we're going to swap this unit out and replace it with a new unit. The gearing mechanism, well, that works perfect now, and the torque loading you can put through this is actually quite sensational considering that this is PLA gears. I will print these in ABS when the design is 100% proven, but for the time being it is really good, and that's just down to the sheer size of the gears. So for this episode, not quite finished the control centering mechanism. It's nearly there. Hopefully the next revision will sort it and the next video will capture it. That's it from Brunei at the moment, guys. I'm going to start work in a couple of hours. I'll catch you later. Sim out.